All right, so we're just going to review really quickly most common ion, some of the stuff that we learned last time, and then we're going to put them together to make the ionic compound. So let's start by finding the MCI for potassium and oxygen. So I'm going to pull out my periodic table, going to look for potassium. Potassium is right here in the +1 column. Okay, so potassium's MCI is just going to be K+. Okay, super easy. All right, for oxygen, we're just gonna go to the other side of the periodic table. If you take a look at oxygen, oxygen is in the -2 column. So you're just gonna have O2-. That's it. That's how you find and write the most common ions. Okay. Any questions about that first one? Hopefully that one's not too bad. All right, so let me just rewrite that for us. So we got O2- and we got K+. All right, and then for number 2, we're just going to be putting them together to write the chemical formula for what happens when these ions combine together. So if we take a look at it, do we have too much positive energy or too much negative energy? Negative, right? So this friend group is a little bit too sad. So we're going to get oxygen one more positive friend, and that's how you balance out the charges. And so since you have 2 potassiums, you're going to write K2, and then you're going to write O. Okay, so there you go. That's going to be your ionic compound that's formed. Okay. All right, so today we're really not doing anything different. We're going to be doing the same thing. The only difference will be that I'm going to teach you guys the way to write something called a chemical equation. This is how we express how things combine and react together in chemistry. So I'm just going to teach you the general format using most common ions, something that you guys should be familiar with. Okay. All right, so I know the name of the lecture is a little bit long, ionic compound chemical equations. Instead of ionic compound, if you just want to write IC, and then for chemical equations, if you want to write CE, that's totally fine. Okay, you don't need to write that full term. The ionic compound, you can just write IC if you want, and chemical equations, you can just write CE. Just keep it simple. All right, so let's talk about chemical equations, and then I'm going to show you guys how they apply to ionic compounds, okay? So again, you guys do not need to copy all this down. I'm going to tell you guys what you need to write down, okay? But a chemical equation is just kind of like a recipe. It tells you the chemicals that you start with, which we call reactants, and then the chemicals that we make, which we call products. Okay, so we do have an example right here, and I do want you to copy this right here, this highlighted part, just so you guys have an example, okay? So in a chemical equation, you have reactants. Those are kind of like your starting ingredients. It's what you start with. And then you have an arrow pointing to the product, so the chemical that's formed when these two things react. Okay. Okay, the key thing to note is that all the chemicals, they are separated by plus signs and the arrow. So just look for the plus sign and the arrow. And anything between those are basically the chemical formulas. Okay, so I have an example right here for you guys. And I do want you guys to copy this down because this is a chemical reaction for what we did for our warm-up. So we have our potassium and our oxygen, and then they combine to make K2O. So copy this down just so you guys have the general format for what a chemical equation will look like. And I'll just explain one quick thing, and then we'll jump right into the practice problems. All right, so again, so hopefully you guys copied this down. And so I'm going to show you guys how to write the chemical reaction really quickly, and then we'll do a couple practice problems. So again, when you have a chemical reaction, you have your 2 starting chemicals. So in our warm-up, you had the MCI for potassium, and then you were combining that with the MCI for oxygen, right? And then we said that when we put them together, we get K2O. So that's why we write them, and you see how they're separated by the plus sign and the arrow. Okay. Now, the only thing that we need to add in order to finish this is we need to add something called a coefficient. You guys might have heard that term in your algebra classes, right? It's the number that goes in front of the variables like x and things like that. And so when you get chemical equations like this, you just need to put a number in front of the chemical. Okay, so let's start with K. How many Ks did we need in order to make K2O? Yeah, 2. So we're gonna put 2. And then how many oxygens do we need? So the charge is 2 minus, but how many oxygens did we use? 1. Yeah, we used 1. So look back at your warm-up. If you guys remember, we had 2 Ks, right? We had K plus, and then we only wrote down O2 minus 1 time. So you got 2 Ks, so we put a 2 in front of K plus, and we only used 1 O2 minus in order to balance it out. So this is where it can get a little bit tricky because remember this right here, these numbers right here, plus 1 and 2 minus, those are called the charge. So the charge is the energy that the ion has. It has nothing to do with how many you have, right? They can have a lot of energy, a little bit of energy, but it doesn't have anything to do with the number of the ions that you have. So it might get a little bit confusing because we have a lot of different numbers now that we're working with. And that's kind of the trick in chemistry, just keeping in mind what all these numbers mean. Okay, and then when you put all these together, you should get 1 K2O. Okay, so 2 K plus ions and 1 O2 minus ion creates a K2O ion. Okay. And an easy way you can check your work is if you got 2 Ks here, you got to have 2 Ks on the right side. And you got 1 O2 minus here, you're going to have 1 oxygen on the right side. Okay. That's one way to check your work. Yes. So it doesn't matter if it's positive or negative? It does not matter if it's positive or negative. That's for balancing the ionic compound. But the numbers have nothing to do with positive, negative. Yeah, good question. All right. Any other questions? Okay. For sure. Okay, so I know number 1, it looks exactly the same as the previous one. So let's change this to not potassium. Let's change this to aluminum. And let's change this to bromine. Okay, so I'll give you guys about maybe 3 minutes. Try out number 1 on your own, and then we'll go over together, see if you guys get the correct answer. And then I'll show you guys what the chemical equation looks like in 3 minutes. Okay, try that out. Okay, so for number 1, let's find the MCIs first. Okay, so if we take a look at the periodic table, what's the MCI for aluminum? Yeah, 3 plus. It's right here. So Al 3 plus. So let's write that down. I'm gonna write Al 3 plus. Next, we're gonna look at bromine. So if you take a look at bromine, what's bromine's MCI? Yeah, -1. It's in the -1 column. So you're gonna have Al 3 plus, and you're going to have Br minus. Okay. All right, so far so good? Okay, so we're gonna write the chemical equation. So what we're trying to do is we're trying to see what happens when we combine these two. So we'll put a plus sign between them. And we're trying to find out what they're going to make. So we're gonna draw an arrow. Okay. All right. Now what we need to do is we need to balance out the positive and the negative energy. So do we need more positives or more negatives? Yeah, we need some more negatives, right? Okay. So we got +3 and -1. So how many total bromines do we need to balance this out? 3. So all you're going to do is don't change anything about this. Just put a 3 in front of Br minus. And then we just put a 1 in front of Al 3 plus, just to show that we only need 1 aluminum and 3 bromines. That's it. You're done with the left side of the arrow. All right. And then for the right side of the arrow, all we need to do is write Al. And we're combining it with Br. So Al Br 3. Okay. And your answer should look exactly like that. If there's anything different, you did something wrong. Okay. All the numbers, all the ions, they need to be in those exact spots. Yeah. Okay. All right. Any questions about that one? Yeah, what's up? Yeah, we determine how many we need. By that, we use the charges. So you see how it's +3 and -1, right? And so in order to balance out the +3, you need 3 of these guys. The 3 in the front just means that there are 3 VR minuses. That's what that means. Does that answer your question? Alrighty, guys. So let's do one more together. This is the last practice problem we'll do for the lecture. I'll give you guys about 3 minutes to do this one, and then we will go over it and then move on to the assignment. Okay, this one's a little bit different because you have U4 plus, so this one's not looking for an MCI. It's actually easier, I guess, then. So you got U4 plus, and you're combining it with oxygen's MCI. We already said that that's O2 minus, okay? All right, and then we're combining these guys together, and we're trying to figure out which ionic compound we make. So let's balance out the charges, okay? So you'll notice that this one is +4, this one is -2. So that means we'll need more oxygens, obviously. So we'll need 2 total O2 minuses to balance out 1 of the U4 plus. Okay, so your left side should look exactly like that. Okay. And then on the right side, you put all those together, you're gonna get U, and then that's gonna combine with the 2 oxygens to make UO2, and you're only gonna make 1 of that molecule. So there you go. So again, your answer should look exactly like that. If anything is different, if the numbers are in a different spot, if the ions are in a different spot, then it's incorrect. So if you guys have any questions, I know the formatting is very particular and it might be a little strange right now. If you have any questions, please let me know so I can help you out, help clarify things. But I'll give you guys the rest of the class period to work on your assignment and the quiz for today, okay?